China has completed one of the most remarkable projects in the history of mankind. Not just a small platform, but the entire city with homes, schools, parks, and a bustling economy is built on the vast open sea. Seems impossible? Right. But China has actually made this impossible task possible. A city that does not exist in the world before 25 years, but now it is added to the world. But how? How China literally built a city on water. What are the science and technology used here? Which material is used? How the foundation is laid? We will understand everything in detail in today's video. This is the new city, located in Pudongnu area of Shanghai in China. This is spread over an area of 315 square kilometers, and it can accommodate over 800,000 people at present. Elon Musk has also chosen this city for constructing the Tesla Gigafactory in China. Actually, in the 2000s, China was growing at an unimaginable rate. Its cities were expanding, and urban populations were skyrocketing. Then the government of China faced a crucial question here. How do we expand urban spaces? And here's where the idea of Lingang New City was born. By building a new city on the sea, China would not just be expanding its area, they'll be creating a whole new living experience. This idea was really very fascinating, but also very challenging. Building on the sea brings unique challenges. There were actually 4 big concerns. That is, appropriate site, highly buoyant material, strong floating foundation, and the 4th is the construction. So how did they achieve all these? Let's see. Selecting a site for a city, especially on the sea, is critical, because not all parts of the sea are suitable for construction. They needed a location with relatively calm waters, safe from strong currents and typhoons. And also, the site must near a big city so that it can support in reducing urban density and also boost China's economy by attracting tourism and investors from all over the world. After extensive research and testing, engineers selected a site near Yangshan Deepwater Port in Shanghai, where conditions were ideal for stability and safety, allowing construction to progress without constant disturbance. And also Shanghai, as one of the most iconic cities in China, was feeling the pressure of overpopulation. So if they could find a suitable site near Shanghai, it will be a cherry on top. Later, they decided to make this city a smart city. So they changed the name of the Lingang New City to Nanhui New City. Nanhui New City was not just an engineering marvel, it was also a strategic move for China's economy, because in its very first year after completion of major phases by 2021, it has generated over $10 billion in revenue. Now, the next big challenge is the materials. The materials should be highly buoyant, light-weighted, and also strong enough to hold big buildings. Mainly, there are 3 kinds of materials used here in this project. The first is HDPE, means high-density polyethylene. HDPE is a durable plastic material. This is the most commonly used materials in any floating platforms because this is very light-weighted, buoyant, and corrosion-resistant. For floating walkways or light infrastructure, HDPE is often used as a structural material to create buoyant platforms that remain stable even in changing tides. Now, the second material used here is the geotextile fabrics and geosynthetics. Geotextiles are used for soil stabilization and in controlling soil erosion, especially in artificial islands or floating structures. The speciality of this material is that these fabrics allow water to pass through while retaining soil. Now, the third material used here is GFRP. GFRP is corrosion-resistant material and are even stronger than the steel. It is used for lightweight structures that need strength without adding too much weight. The combination of these advanced materials enabled China to experiment with sea-based city project on a massive scale. Now, the most challenging task of this entire project was to lay a strong foundation on the seawater. Engineers and architects spent years studying similar projects worldwide. learning from their successes and failures of floating structures around the world, like the Netherlands, Maldives, and Singapore. These countries have also built some floating houses and structures, but not at this massive scale. Solving these challenges took years of innovation and collaboration with some of the best engineers worldwide. So how did they solve this problem? They developed 3 techniques to solve this. The first technique is the pontoon foundation. Actually, pontoon foundation is also used in creating platforms on the sea for extracting petroleum oil, but not at this large scale. Pontoons are made of reinforced concrete. These concretes are often mixed with polymers or coated to make it even more buoyant and stronger. The invention of pontoons helped a lot to make this dream possible. These pontoons are incredibly buoyant and can float even with heavy buildings. Now, the second technique is the anchoring systems. A floating city's stability relies heavily on anchoring techniques to keep them stable in the ocean especially. China has implemented advanced chain anchors that fix this floating foundations to the seabed. These anchors were allowed to slight movements to absorb wave forces without compromising stability, which is essential for minimizing damage from strong storms or tidal forces. Now, the third technique used here is creating artificial land by using all the 3 materials that we have discussed before. That is HDPE, geotextiles, and GFRP. These innovative techniques and advanced materials helped engineers and architects to create a strong floating foundation, even on the sea. This is really incredible. Now the foundation is ready, it's time to start constructing the city. The infrastructure of Nanhui New City is carefully crafted in a circular design with large artificial lake at its center. This design is not only visually striking, but also grounded in deep scientific principles. One of the key reasons for a circular layout is the stability. A circular design allows wave energy to dissipate around the structure evenly and are more stable than any other shape. You might be thinking that a triangular shape can also reduce the impact of big waves in the sea. Yes, it can definitely reduce the impact of big waves, but designing a layout in circular shape is much more stronger than the triangular shape. I think that's why God made everything circular. Earth, moon, sun, eyes, nose, bum.